ahead and get started. So hello, everybody, and welcome to the training workshop on the 2025 Technical Guidance Manual for Stormwater Quality Control Measures, otherwise known as the TGM. My name is David Lack, Stormwater Resources Manager with Ventura County Public Works Agency Watershed Protection. And I just wanted to go over a few housekeeping items. First, please mute your microphone during the training. And for any questions you may have, please put them in the chat. At the end of the presentations, we will have time for the question and answer. We should have plenty of time for that. And we'll address the questions that have been submitted in the chat. Also, I want to note that this training is being recorded and the recording will be posted on vcstormwater.org after the meeting. Additionally, the questions that are submitted via chat will also be included in a Word document with the answers drafted in response. That document will be sent out to all the meeting participants along with the link to the recording, probably in about a week or two from today. I also put the link to the 2025 TGM in the chat so that you have access to it. So again, welcome everybody. And with that, let's get started. And I'll hand it over to Haley Luna to get the workshop underway.
Good morning. Welcome to the 2025 TGM training seminar. The Ventura County Technical Guidance Manual for Stormwater Quality Control Measures is our main topic today. We will often refer to it as the TGM throughout this training. This training is put on by the Ventura Countywide Stormwater Quality Management Program. So our presenters today include myself. I'm Haley Luna, Deputy Director of Ventura County Watershed Protection District. I also serve as Chair for the Ventura Countywide Stormwater Quality Management Program, and I oversee the county's MS4 permit program, which includes implementation of the TGM requirements in the unincorporated areas of the county. Peter?
Thanks, Haley. My name's Peter Schellenbarger. I'm with the City of Ventura Public Works Department. I oversee the city's MS4 permit program. I'm also the chair of the Planning and Land Development Subcommittee for the Countywide Stormwater Quality Program. Ty?
Thank you very much, Peter. Good morning, everybody. This is Ty Chow, Assistant Community Development Director and City Engineer for the City of Oxnard. I oversee the land development over here at the City of Oxnard, and as well as the Stormwater Review Program. And we are looking forward to present to everyone today and sharing with you about the new TGM and its technical guidance manual. David?
Hi, everybody. It's me again, David Lack, Stormwater Resources Manager with Ventura County Public Works Agency Watershed Protection. I help coordinate all the countywide stormwater program activities. So the monitoring, reporting, the public outreach and special studies, and kind of act as a liaison between the permittees and the regional board. And I'll hand it back to Haley.
Thanks, Dave. All right, so our agenda today, I'm going to start going over a little bit of information regarding local land use authority and our countywide stormwater program to kind of orient the discussions today. Then Peter will be going through some background on water quality and the 2025 TGM, as well as some components of the 2021 regional MS4 permit. Ty is going to be your favorite person today because he's going to get into the details of the calculations and walk through some of the BMP sizing calculation examples. We're hoping to save at least half, maybe even more of the time we have today for questions and answers. So first component of the presentation here, we ask you to put any questions you have in the chat. We expect to have a lot of time for questions in the second half of the program. So local land use authority. This is an important concept when it comes to who you're submitting your development applications to when you're doing a project. The table I have on the top of the slide here is a list of all of the different MS4 permittees on the regional MS4 permit for Ventura County. So as you can see, the cities, the county, and Watershed Protection District are all separate permittees on our regional MS4 permit, which is our municipal separate storm sewer system permit. So that's our storm drain system permit. In order to operate our permits, we have to comply with our systems. We have to comply with the terms of the permit. And the reason this comes up is because each of these permittees has local land use authority, with the exception of watershed protection, which I'll talk about in a moment. But that means that each of these municipalities is responsible for implementing the planning and land development requirements of our MS4 permit within their local jurisdiction. So the county does not have jurisdiction over the cities in any way. The county simply implements those requirements within the unincorporated areas. The exception, the outlier on this is Watershed Protection District. Watershed Protection's jurisdiction does cross the city-county boundaries because they operate their channels. However, Watershed Protection does not have land use authority. So if you are doing a private development project, Watershed Protection is not the one who's approving your permit. If you're applying through the county because it's in the unincorporated areas, that is the county's local land use authority. It can get confusing sometimes because our county stormwater program, which reviews development projects in the unincorporated areas, is housed within Watershed Protection District. But according to how our local land use authority and our MS4 permit is structured, they're actually separate authorities. And so we want to clarify that because you'll notice that we're going to talk a lot about referring to the local land use authority or the permitting agency when you have questions about details for a specific project. Together, the cities, the county, and watershed protection make up the Ventura Countywide Stormwater Quality Management Program. So the countywide program, as we refer to it, is a partnership among all the cities, the county, and watershed. It's governed by a management committee, which includes representatives from each agency that provide direction on how these county-wide programs should operate. However, it also has several subcommittees. So the one that comes into play today is the Planning and Land Development Subcommittee. This is the component of our MS4 permit that the TGM requirements fall under. And so Peter is the chair of our Planning and Land Development Subcommittee. So he'll have a lot of great topics since that subcommittee was responsible for developing the 2025 TGM. I serve as chair for the management committee for the countywide program and support all of the initiatives that the different subcommittees work on, as well as all the representatives from the different agencies. Each agency has representatives that attend each of the subcommittees to provide local input from their municipality and how they are implementing requirements of our stormwater permit. So that's some brief background. Peter's going to get into a little bit more detail about water quality.
Thank you, Haley. So yeah, we're going to kick off this next topic just as a water quality background. So next slide. So water quality is managed locally by the Los Angeles Regional Water Quality Control Board. The regional board issues discharge permits and waste discharge requirements for point and non-point discharges associated with urban areas, agriculture, industrial, construction zones, septic systems, sanitary and collection systems, and groundwater. Really, the mission of the regional board is to preserve and enhance water quality in the Los Angeles region for the benefit of present and future generations. I literally took that off their website. But I just want to note that the local land use authorities are required to implement the MS4 permit and these discharge requirements as written, and we do not create the requirements, we simply implement them and follow them. Next slide. So the Los Angeles Regional Water Quality Control Board has adopted 4 MS4 permits in the county. The first was adopted in 1994, Ventura County MS4 permit. The second was adopted in 2000, which was also a Ventura County only MS4 permit. The third was adopted in 2009, was challenged and readopted in 2010, only Ventura County permit. And then the fourth and current MS4 permit for Ventura County is a regional, which includes Los Angeles County and Ventura County under one regional permit, and it was adopted in 2021. And each permit includes more stringent and prescriptive requirements as more information and data is available. Next slide. The regional phase 1 MS4 permit has 6 minimum control measure programs. These are required programs that each agency is required to implement. We will be talking about the planning and land development program specifically today. This relates to post-construction B&P implementation, also known as low impact development. So next slide. So what are the goals of the planning and land development program? Well, it's the mitigation of potential pollutants from urbanization and urban surfaces, the implementation of non-structural best management practices, and the construction and implementation of structural best management practices. It's really focused on source control and site-specific source control to control potential pollution where it is generated. Next slide. So the planning and land development program and the MS4 permit is linking land development and urbanization to water quality impacts. There can be loading of sediment, nutrients, metals, pesticides, bacteria, oil and grease, gross solids. And it's noting that poorly planned and constructed new development and redevelopment projects have the potential to impact hydrology and water quality of surface waters. So we're talking about increasing peak storm stream flows, increased pollutant loading, and reduced base flows downstream. Next slide. We want to note that US EPA and the California Water Boards are really looking at a paradigm shift. So moving away from curb and gutter, transporting stormwater quickly away from development projects, and moving away from small footprint flow-based treatment approaches, and moving the state towards the concept of managing stormwater the way that natural environments do, through infiltration, evapotranspiration, capture and reuse, biofiltration. And in doing so, this can promote healthier soils, can recharge groundwater, can provide flood reduction benefits, reduce urban heat island impacts, improve water quality, etc. The next slide. And so this is just an example of a post-construction B&P at a city capital improvement project. This is a city park, Kellogg Park, on the west side of the city of Ventura. Not only does it provide recreational benefits and opportunities for the community, but it also provides an educational component where we're teaching about low impact development. What you're looking at here was actually the first rain that happened to I should say, collect in these infiltration areas, percolate into the soils. So it's taking runoff not only from the park itself and surface flows from the park, but also diverting off of the city streets and right of way. Next slide. So the next topic is really just, hey, we updated the technical guidance manual. So next slide, this is just general information. And so the 2025 Ventura County Technical Guidance Manual for Stormwater Quality Control Measures was created to reflect the changes in the 2021 Regional MS4 permit. So the majority of the content within the 2025 TGM is the same as the 2018 TGM. However, we shifted information into different sections to try to improve the readability and the use of the document. And I will note that the 2025 TGM should apply and be used for entitlements and new projects that are not deemed complete for stormwater mitigation by May 12th, 2025. And if you have any questions about that, what is deemed complete for stormwater mitigation, please reach out to your local land use authority for clarity. Next slide. I want to note that the 2025 TGM is a tool to assist in design of post-construction stormwater treatment B&Ps that meet the 2021 regional MS4 permit requirements. Each MS4 agency has different submittal, review, and approval processes for stormwater compliance. What you're seeing, this image on this slide, is what the city of Ventura requires for entitlement projects. and is called their Stormwater Compliance Study. The city of Oxnard, Santa Paula, County Unincorporated, Ojai, they all might have a different process or submittal requirements. So please reach out to the local land use authority or visit their websites for more information. I will note that the MS4 agency's collective goal in the 2025 TGM is to improve the chapter structure, to update equations and worksheets, to improve its use, not only for the development community, but also to speed up agency review. Next slide. Each TGM version has really built upon the past versions, with the first TGM released over 20 years ago. So the 2002 TGM reflected the 2000 Ventura County MS4 permit requirements. The 2011 TGM, the updated 2015 TGM, and the updated 2018 TGM reflected the 2010 Ventura County MS4 permits requirements. And finally, the current 2025 TGM reflects the 2021 Los Angeles Regional MS4 permit requirements. And as I noted before, the TGMs are being updated for consistency with current regulatory requirements, and when we might find something that needs to be improved, we take it upon ourselves to update it. Next slide. And so the TGM, as I said, is a tool that provides resources and specifications to comply with the regional phase 1 MS4 permit. Next slide. And Los Angeles County and Ventura County now have the same planning and land development requirements because we were under the same permit. And these requirements are very similar to the 2010 Ventura County MS4 permit and the 2012 Los Angeles County MS4 permit. Next slide. Just to reiterate, the 2021 MS4 permit, just like the previous MS4 permits, require agency review, approval, and plan checks to ensure that the new and redevelopment projects are implementing post-construction BMPs as requirements as outlined by the permit itself. These are strict adherence to MS4 permit requirements that the local land use authority needs to ensure are being met. Planning and land, or I should say new and redevelopment projects that are triggering the planning and land development requirements require operations and maintenance plans and maintenance covenants to ensure that long-term maintenance is provided to these BMPs in perpetuity. I will note that routine maintenance of the right-of-way, emergency work, reconstruction of parking lots that keep existing line and grade, and the implementation of ADA requirements that also maintain existing line and grade do not require stormwater mitigation incorporation typically, but if you have questions regarding what is referred to as routine maintenance, please reach out to your local land use authority for clarity. Next slide. So new and redevelopment projects are complying with the 2021 regional MS4 permit, not the 2025 TGM. Each individual local land use authority may condition your project to comply with the 2025 TGM and the specifications within it, but the regulatory requirements are within the 2021 regional MS4 permit. The 2025 TGM is intended for projects to rely upon for design specifications and calculations to assist with the design and construction of post-construction BMPs. And as noted before, if you have project-specific questions about treatment or constraints of a site, it is always best to engage your local land use authority early during the entitlement phase so that you can work out any challenges early on to not slow down the project during entitlement and approvals, and so that it doesn't occur during plan check. Next slide, please. And so in the next few slides, what you're seeing in red is just a change. I just want to highlight changes under the 2021 MS4 permit that are important. And so with regards to hydro modification management requirements, Priority development projects within natural drainage systems in Los Angeles County are required to implement hydro modification controls. But only priority development projects disturbing land areas of 50 acres or greater in Ventura County are required to implement hydrological control measures. And so this should decrease the number of projects subject to hydro modification management in Ventura County, and it may require more projects in Los Angeles County to control for hydro modification. Next slide. In terms of water quality and flow reduction requirements, I just want to highlight that the stormwater quality design volume is the volume of water that post-construction BMPs need to mitigate. And it has been updated in the 2021 MS4 permit. So the SQDV is defined as the greater of the following: the runoff from the 3/4 inch 24-hour rain event, or the runoff from the 85th percentile 24-hour rain event. In the 2010 Ventura County MS4 permit, this was an or, but under the 2021 MS4 permit, this is whatever is greater between the two. I will note that the 85th percentile 24-hour rain event is available on a GIS web-based map on the Ventura County GIS portal. It is linked in the 2025 TGM document, so it's very easy for projects to identify the 85th percentile 24-hour rain event right now. The stormwater quality design volume is a flow-based measurement. And to utilize flow-based measurements under the 2021 MS4 permit for post-construction BMPs, you need to have the executive officer approval from the Los Angeles Regional Water Quality Control Board. You will need to filter or treat the maximum flow rate of runoff produced from the annual intensity of 0.2 inches of rainfall per hour for each hour of a storm event, or the maximum flow rate of runoff produced by the 85th percentile hourly rainfall intensity. It also needs to be certified for enhanced metals treatment under the Washington State Department of Ecology's TAPE program. Next slide. For changes under the 2021 MS4 permit that are for infiltration and feasibility, under the 2010 MS4 permit, technical infeasibility for infiltration was infiltration rates less than 0.5 inches per hour. Under the 2021 MS4 permit, it is infiltration rates that are less than 0.3 inches per hour. And I will note that it is not technically feasible to amend the local soils to attain an infiltration rate necessary to achieve reliable performance or infiltration. The above noted rates is not BMP design percolation rate, but rather the existing native soil infiltration rates. And the BMP design percolation rates used for sizing BMPs shall not be used for determining on-site retention infeasibility. Next slide, please. So the structural BMP water quality mitigation hierarchy, or the steps to identify what type of BMP to implement on site, has not changed. The approvals have changed, but Ty will go into that a little later today. So the first priority outlined in the 2021 MS4 permit is on-site infiltration, bioretention, or rainwater harvesting and use, which is a BMP focused and sized for a volume of water. This is retaining the water on site. Now, if the first priority is above is infeasible, on-site biofiltration, off-site groundwater replenishment, and or off-site retrofitting, using a BMP that is sized for a volume can be pursued. And if priorities 1 and 2 are infeasible, then on-site flow treatment can be pursued, which is a flow-based or a flow-sized BMP. However, as I noted before, this requires the executive officer approval from the Los Angeles Regional Water Quality Control Board. Next slide. I'm not going to be talking about retention, only the alternative compliance and on-site biofiltration. So on-site biofiltration continues to biofilter 1.5 times the required retention volume. Sizing for on-site biofiltration will always need to be volume-based under the 2021 MS4 permit, and it cannot be flow-based. And biofiltration typically does not include proprietary biofiltration or any other high-flow biotreatment devices with an impervious vault and underdrain as defined by the Regional Water Board. So in the image to the right, you're seeing a biofiltration system that was designed per the technical guidance manual. Next slide, please. Alternative compliance for offsite mitigation measures. There's also a way to comply with the planning and land developments program if on-site retention or on-site biofiltration is infeasible. But I will note that offsite mitigation is available, but it is really dependent upon an available agency's programs or ability to retrofit another private development, an existing private development, I should say. So offsite infiltration projects and groundwater replenishment projects, if a project is looking for alternative compliance for offsite mitigation and you have questions about if offsite infiltration or groundwater replenishment is available in the subwatershed, please reach out to your local land use authority for questions. These regional, I will call them regional projects, must be situated in the same HUC 12 watershed as the newer redevelopment project. Also, offsite project retrofits. This is also reach out to your local land use authority for availability. However, it is also good if you have or can partner with another private development to retrofit in a similar existing land use. Any offsite alternative compliance offsite measure needs basic tape BMP treatment at the newer redevelopment project. So you would need to treat the water using basic tape BMPs of the newer redevelopment project, as well as have an offsite mitigation effort. So keep that in mind. Next slide. Under the alternative compliance on-site flow-based BMPs under the 2024 MS4 permit, there's a little bit of a change here in the approval process. So if a permittee determines that on-site biofiltration and off-site alternative compliance measures are not technically feasible, the permittee may request the executive officer allow the use of on-site flow-based BMPs. And in the request, the permittees must outline why none of the other alternative compliance measures are feasible. And approval will only be granted to areas where other alternative compliance measures are not feasible due to significant technical issues. So typically, you want to be discussing this with your local land use authority very early on in the entitlement phase, because typically the local land use authority will want to have executive officer approval before a project is entitled. The permittee will submit on behalf of the newer redevelopment project that is pursuing alternative compliance via on-site flow-based BMPs. However, the local land use authority will not be generating this document. It will be the responsibility of the private developer to create documents that will be submitted on their behalf by the local land use authority. On-site flow-based BMPs, as noted earlier, are going to be typically a CFS-sized BMP, and they are required to be certified for enhanced or metals treatment under the Washington State Department of Ecology's TAPE program or an approved future BMP certification developed by the state of California. And I will note that there is not a program right now for the state of California for approved BMPs. Next slide. And I will pass this over to Ty now to get more into the technical work.
Thank you so much, very much, Peter, for that overview of the MS4 permit and the TGM. For this section, everybody, what I'm going to focus more is on the technical aspect of the TGM and also giving everybody a quick overview of the 2010 MS4 permit requirements. And the reason I want to do that is because to give us a sense of what was required before, and then we'll compare that to the 2021 MS4 permit requirement. Then we go into the 2025 sizing calculation. And again, do a little bit of comparison. We'll look at common required items, the remove required items, the new and modify required items, as well as civil sizing calculation for your benefit. Next slide, please. So this is a quick recap of what Peter was describing, but this is more of the numerical aspect of the MS4 permit. We have 10 different categories here for the new development triggers. For the most part, I think a lot of people are going to be focusing on item number 1 or category number 1, which has to do with the disturbance of land more than 1 acre with 10,000 square feet or more of impervious area, right? And then we go down to the industrial park, commercial, strip malls, retail, gasoline, restaurant, parking lot, and so forth. It also includes, by the way, streets and road reconstruction or construction that are adding 10,000 square feet or more of impervious area. When it comes to redevelopment, we want to make sure that everybody understands the 50% threshold. And of course, the trigger is when you are creating, adding, or replacing 5,000 square feet or more of impervious area on an existing project site. Next slide, please. So when it comes to the BMP selection, this is essentially the priority in which we like everybody to go through. And this is what the MS4 permit is also guiding us. The first priority is obviously infiltration-based BMP. We want to have a system that can collect, pre-treat, and then infiltrate the runoff via surface or underground. Typically, this includes infiltration basin, infiltration trench, bioretention, dry well, as well as permeable pavement. Then the next categories are in the case that the soil cannot actually have adequate infiltration rate, then we move to biofiltration. So these devices essentially intended to collect, treat with vegetation, a soil media section, and then release. They include biofiltration, obviously, as well as planter boxes, bioswale, and filter strip. And again, I want to mention to everybody again here, this is from the 2010 MS4 permit, which is for the 2018 TGM. So this is just a baseline that we are going to see the comparison between this previous version versus the version that we have now. Lastly, but not least, we have the proprietary treatment devices that is essentially treat with vegetation, but the soil media is extremely engineered with a very high infiltration rate. So typically you see modular wetland system. Ventura is probably one of the most popular one we have seen out there. Next slide, please. All right, so here is essentially the 2021 MS4 permit with marked changes compared to the 2010. So on the top there, you can see under new development trigger, they are now removing the term strip from malls. So it is commercial mall, that is it. And the alteration to that definition too is also total altered surface area. So there's no impervious. So if you go to a project site that is essentially a mall, and you are altering 10,000 square feet or more of surface area, then in that case, the project will trigger the new development. So going down to the redevelopment triggers, these new 2021 MS4 permit does provide a lot of clarity as far as what kind of redevelopment it is, right? And so what we see here is that if anybody has a project that creates, add, or replace 5,000 square feet or more of impervious area over the entire project area, right? So if that is for an existing site of 10,000 square feet or more of impervious, or if you have an industrial park with the same area, or if you have commercial mall of 10,000 square feet or more of surface area, those are the things that everybody is going to have to pay attention to when you have a redevelopment project site. The 50% rule is still applies to the redevelopment. So looking at your project site, looking at how much you are intending to replace, those are going to be quite important because that may mean treating the whole entire site or only treating with the improved area that is being proposed. So for the bottom one, this is a mixture of new / redevelopment trigger, and this applies to restaurant, parking lots, automotive facility, retail gasoline. Notice that we no longer have the parking count for the parking lot. And so it is quite important to pay attention to the trigger and the amount of impervious area, and then selecting which project applies to your project that you are doing. Next slide, please. So in this section, we are talking again about the stormwater performance criteria, right? And so we're still looking at doing infiltration-based BMP, and this is what Peter has conveyed previously on his slide. We want to collect, pre-treat, and infiltrate. The systems are essentially identical to the previous requirement. We're talking about infiltration basin, infiltration trench, bioretention, dry well, permeable paver. And then the next one is biofiltration. Note here that biofiltration is now SQDV, which is volume-based sizing. And we only have biofiltration and planter box. Bioswell and biostrips are no longer considered a biofiltration BMPs. However, they are considered as pre-treatment BMP if such pre-treatment is proposed for, let's just say, an infiltration basin. That is still appropriate. And thirdly, but not last, the flow-based treatment is still on the permit. It is still permitted, of course, via the executive officer approval. And it's essentially what we have last time, which is treat with vegetation, engineer soil, or device, and then release. Again, modular wetland, Ventura are the two popular systems that we have seen repeatedly proposed on many project sites. Next slide, please. So here is a slideshow showing the technical similarity and differences. The soil infiltration rate we've seen in the last TGM indicating, 0.5, but what I want to emphasize here is that the 0.3 inches per hour is still that philosophy of making sure that the infiltration base can function properly. And then we also have the pre-treatment 4-bay requirement for infiltration-based basins. We still have the 5 feet above the seasonal high groundwater, just to make sure that we don't get those basins too close to the seasonal high groundwater. And then, of course, we still require the 150% SQDV volume for the biofiltration-based BMP. The SQDV equation, which is based on the 3/4 inch or 85th percentile 24-hour event, is still the same. The equation is still the same. There has not been any changes on that equation. The SQDF equation, again, it's still the same thing, right? And even though the 85th percentile hourly rainfall event is also a criteria, I think most of the project are going to use the 0.2 inch per hour just because that's just easier and readily available. The things that have been removed from the 2025 TGMs are the 5% EIA, right? The A retain that has been retained. It is now replaced as a project or a tributary. The bioswell and filter strips as primary BMPs, those has been removed, now considered as pre-treatment. And the 80% average annual runoff volume, that has been removed. The items that this new TGM is modifying are the 85th or the 3/4 inch or 85th, whichever is higher. This is what Peter was talking about before. And of course, it is very important to go to the GIS map, locate your project, understanding what is that 85th. Sometimes it is lower, sometimes it is higher. Certainly for the city of Oxnard, I would say the vast majority of them are lower than the 85th, except for the northerly easterly portion of the city, which has a 85th percentile rainfall event much higher than 3/4 inch. The item that we have been that has been added to the TGM is the drain rock section. It is now specifying the Caltrans Class 2 permeable material. This material is very, it has a self-filtering mechanism and does not need filter fabric. So that is going to be a very nice addition to the system and removing that engineer fabric away and from the system to improve the flow rate. And this is not to confuse with Class 2 base rock, just to make sure. And lastly, but not least, this is really, really important to pay attention to. if for whatever reason the project is using an off-site mitigation, meaning provide mitigation at another project far away from the project site, the project site is still required to provide a tape basic treatment, which has to be sized for the 1 year, 1 hour event, not the 0.2 inches per hour, but the 1 year, 1 hour. In most cases, this could be double or 3 times the amount of the typical flow rate. So be very cognizant of that if you are proposing to use off-site mitigation. Next slide, please. So I have, I'm going to present 3 examples. One is going to be infiltration-based BMP, which is usually number 1, 2, and 4. And then we're going to be talking about the biofiltration-based, which is bio 2, should be bio 1 and 2, I'm sorry there. And then the flow-based, we have flow 1, 2, and 3. So I'm going to go through those 3 examples, and I think I'm going to emphasize keeping it basics, right? That's the intent of this new TGM, is that keep it basics, keep it focused, because we all want everybody to size the system quickly and understanding the requirements. Next slide, please. Okay, so when it comes to infiltration-based BMP, again, it's simply to collect, pre-treat, and then infiltrate. The SQDV equation that you see here is very much the same as before, and it's really simple. It's only depending on 3 things. The first one is the runoff coefficient. This is the composite coefficient. Whatever it is, your project site may have 2 tributary area, or you may have a project that is just simply 1 tributary area. In this case, that's the equation that we see here. But the runoff coefficient that we are showing in this example or this equation is that you want to make sure that it is a composite, meaning it is a mixture of the impervious and pervious area within that tributary. And then we're talking about the P, which is the 3/4 inch, or the 85th, which one is higher of the 2. And then the A project, which is A tributary as well. So this equation is pretty simple. All it is doing is calculating that rainfall volume that is landing on the project. Next slide, please. And this is the 85th percentile 24-hour event GIS map from the county of Ventura. So this is something that everybody would need to do to go in and locate your project, and making sure you have that 85th percentile rainfall event and identify it, making sure that it is indeed higher. If it is not higher, then you go back to the 3/4 inch. Next slide, please. Okay, so when it comes to the sizing of the system, what you want to do is that you want to use the TGM worksheet in your design calculations. I understand that some people may want to modify and make their own. And in most cases, that is okay, but we highly encourage to use the worksheet. The reason why is because the worksheet is very familiar to all of us as the governing agency. So if we see something that is familiar, it allow us to review the project quicker, and being able to locate the volume, locate the project area in a very efficient manner. So please do use the worksheet in your design calculation as you submit them to them for entitlement purposes, as well as construction documents. So in this example, we have a project site that is 10 acres with 60% total impervious, right? And of course, for the simplicity sake, we are using the 3/4 inch. So it's simply a plug and check. We have 10 acre. We have a C composite of 0.59, and then we have the rainfall depth with this, which is 3/4 inch divided by 12, and that is what we get, 0.06. I think it's 0.0625 if you want to carry out the decimal. But in essence, you just plug it in. It's 43,560 multiplied by C, which is 0.9, multiplied by P, which is 0.06, multiplied by 10 acres, and that will produce you the cubic feet of volume of SQDV. There are no other unit conversion required. This equation takes care of all of that for you. Next slide, please. Okay, so we talked about the importance of making sure that the soil can actually infiltrate. So making sure that before you set out to do a project, before you set out to select a BMP, you want to make sure that you go through the process and do an on-site infiltration test, preferably at the location that you are intending to propose the BMP. So making sure that the testing requirement follow the guidelines for technical investigation and reporting for low impact development stormwater infiltration from the LA manual. We do have a link in the TGM, so all you got to do is click on that link, and also making sure that the reduction factor, that you applied that reduction factor when you convert it into P measure. However, the infiltration rate of 0.3 inches per hour is the applicability for invisibility. So before applying the reduction factor. So make sure you review that very carefully before you go down the route of choosing a system, whether it is a biofiltration or infiltration-based system. But essentially what you have here is, once you have that P measure rate, you simply go to the process and apply the percolation correction factor from the TGM itself. This, in essence, is a long-term based factor that allows the system to function as intended over a long period. And at the very end of it, what you have is a P design rate that is significantly lower than the P measure. The percolation rate correction factor, SA and SB, are going to be based on your judgment on what you think is the best, based on the design and the construction, as well as the physical location of the BMP. Next slide, please. Okay, so this is probably this slide right here is very critical for a lot of engineers from my professional experience. Now we know the volume, right? Now we know the infiltration rate. So how do we find out the required area? So in this example that you see here, we actually have two different options. So what you want to pay attention to here is the Dmax. The Dmax is the maximum depth of ponded water, both on the surface and in the soil and the rock, that is allowed based on the natural infiltration rate of the soil at the project site. So in this case, we have 2.64 feet as the maximum. And then on this worksheet, you enter the DP, which is the ponding depth. And the ponding depth is essentially, it has to be less than the depth of the Dmax minus the depth of the soil. So it is basically, if you work the other way around, what it's saying is that the DP, if you look at that figure on the right-hand side there, the DP plus the NT multiplied by the DT shall be equal to or less than the Dmax. That's what it's saying. So that figure is something that you got to pay attention to. And then lastly but not least, you want to figure, once you plug in all of that, you want to figure out the footprint of your infiltration basin. And there are two equations that you got to pay attention here. One equation is for the infiltration basin. That infiltration basin, meaning you are just using the surface ponded area, meaning there's no rock, there's no soil underneath, it's just an excavated basin. In that excavated basin, most likely it's all dependent, majority on it is on the DP. If you look at that equation on the bottom right-hand corner right there, equation, let's see here, 3, calculate infiltration area. And if you are proposing to have a basin with amended soil in it, then in that case, you want to include the trench, which is the NT multiplied by the DT plus the DP aspect. So the result I have here is, for the AB, is 6,285 feet for the infiltration basin with the soil, right? And then of course, it is 13,142 without the soil. So you can see the significant difference between the two when you include the soil. So in most cases, if you have an infiltration basin and the footprint is so large, then in that case, you're going to be looking for to have a soil media section, which is, by the way, now turn it into a bioretention basin. But the soil media section is going to be quite critical to your project design idea as you're working out to making sure that the footprint is not too large that it's taking up too much space, or if the footprint, or if you're looking to fit the area to certain footprint. Obviously, there's a trade-off. The trade-off is that the surface-based infiltration basin is easier. You just excavate, you just hydroseed it, and that's it. If you are doing a bioretention base, which is the surface versus the soil, potentially versus also the rock, you're going to have to dig that trench. You're going to have to dig it out. You're going to put the rock back. You're going to put the soil back. So that's more, more construction, more cost, all those things. Those things are the things that, as a designer, you will need to think about on how you want to lay out the system. Lastly but not least, making sure that there is a pre-treatment required, depending on whether you are selecting a surface-based basin or surface or underground or bioretention. I believe bioretention do not require a pre-treatment. It is always encouraged. Next slide, please. So we are moving on to the biofiltration BMP, which is still an SQDV-based treatment system. And in this design here, we are looking at essentially a biofiltration system or a planter box, right? They function identical. And in this example, we are still using essentially the same equation that we have used in the prior example. The SQDV here is the same, is 43,560 multiplied by the depth of the rainfall, which is 0.06 feet, multiplied by the project, which is 10 acres, and multiplied by the composite C coefficient, which is 0.59. And again, we get the exact volume as we did under the infiltration-based design. Now, pay attention. When biofiltration is used, the 150% factor applies. It's not applied here yet. We are just simply getting the SQDV. The 150% factor will need to apply as when you get to the step when you're actually sizing the footprint of the system. Next slide, please. So the biofiltration design for the example that you see here is virtually identical to the previous TGM. This is not a new method. This is the same method that has been presented before. The hydraulic conductivity, which is the KSAT, aka the infiltration rate of the soil media, is going to be the choke factor, right? It's everything will flow as quick or as slow as that soil media. And for the TGM, we highly recommend using a baseline K design of 2.5 inches per hour. So if you look at this system here, the design of the system to satisfy the requirement of the SQDV is essentially the DP, which is the ponent depth of the system. So for biofiltration, which is, let's just say, a system in the parking lot, you have a biofiltration. Typically, we recommend a maximum of 18 inches for that, for ponding. But if you have a planter box that is next to a building where you are directing downspout to, in those cases, we recommend 1 feet or 12 inches. For obvious reason, 18 inches is much more appropriate when you have the system out in the open away from the structure. But as you move it to next to the building, obviously we want to prevent any potential of overflow into the building. So that is generally the recommendation. So as far as the defilter, so now we talk about the ponent depth, which is a selection. And now we're moving to the defilter. The D filter is simply the depth of the stormwater that has been filtered into the soil media section for the first 3 hours, right? And so one component that we recognize here is that the D filter is not the full sections of the soil media section at all. And so this is something that the committee is going to be looking on to see if we need to make revision or not, but we simply want to point that out for the time being. Again, this method was a method that was presented under the previous DGM, and we are simply presenting it again. So when it comes to the calculation of the area here, excuse me, we now need to incorporate back the 150% volume. So for that 150% volume, we want to take that, multiply the SQDV, and we simply divide that by the DP plus the D filter. That would essentially provide the project with the footprint of the biofiltration. Obviously, by doing so, this system is going to be significantly bigger than the infiltration base. So we highly encourage everybody to explore your project site, explore your soil to make sure that you can infiltrate. There is a lot of benefits as far as coming up with a geometry that best fit the project site when a infiltration-based system can be used. But we understand that there are projects that has clay soil that cannot infiltrate. So certainly this biofiltration is also a good system that can be utilized in those cases. Next slide, please. Lastly, but not least, we'll touch really quickly on the flow-based treatment. The equation is quite simple. You know, we're talking about SQDF, which is essentially the runoff coefficient, composite again, multiplied by the rainfall intensity, which is usually 0.2 inches per hour, and then multiplying by the project area or the tributary area. So in this case, we are looking at a tree filter type here, and we have the same project that we have used throughout the presentation. We have 10 acres. The project has 60% total impervious, and then we have a pervious runoff coefficient, we're assuming here 0.05. So using the composite equation, we have a C value of 0.59. And at the very end, we have a flow rate, SQDF, of 1.18 cubic feet per second. So the sizing capacity, the sizing of the SQDV is straightforward, as you can see here. Each individual designer will need to go to the Washington State of Ecology and selecting the appropriate device and making sure that device is the enhanced AKA metal treatment device. And you want to look into each of the device on how they're sized to provide those treatment flow rate. So the capacity flow rate for each device will vary based on who is making it, how they're designing for it. But again, remember, this is, in my opinion, this is the last resort because it will require regional board approval. So I would highly encourage people to go through the infiltration base and then the bio infiltration, and understanding that in some cases we may have to do this flow-based device. Next slide, please. This is a screenshot of the Washington State of Ecology with the selection of the metal treatment. You can see there Ventura, modular wetlands are a couple of the popular one, but it is entirely up to you as the designer to select what's best for your project site. And of course, as Peter mentioned before, please communicate with the responsible agency early in advance if you are making a claim that this is what you need to do for the project sites. And next slide, please. So that's pretty much it for the sizing calculations samples. I look forward to the questions and be happy to provide feedback. Back to you, David.
All right, thanks, Ty, Haley, Peter. We did get some questions in the chat. Feel free to add any while we're going through these first couple. The first one's from Jose. And I'll kind of go in order. Ty, hearing the recommendation to get biofiltration approval during the entitlement phase, should consultants expect an increase in storm drain infrastructure design efforts in entitlement?
I would say no. The bio infiltration or the infiltration-based design guideline has always been as part of the TGM, even from the previous one. From the technical point of view, there has nothing that has been changed for those systems. The only change is now the flow-based treatment is the approval is now reserved to the regional board for approval.
I would add on that if you were not doing a conceptual BMP design at the entitlement phase, I would plan to. And that's what agencies I think are looking for moving forward.
Yeah, and to add to that, I think just reiterating that the system that is being reviewed during entitlement phase should be the system that is pursued during your civil and building plan checks. You shouldn't be changing the system. And at least in the city of Ventura, if an approach changes, then the entire stormwater review process starts over with a review and approvals that you had to submit during entitlement.
All right. And next question ties into that. First question is from Nicole. How long does the executive approval typically take? Haley, any ideas?
Well, so we've never done it before. So we don't have a Ventura County example to give. I do know that it has to go to public comment. So even once it's submitted to the regional board, I think it's a 30-day public comment period. So add on processing time for the regional board to get that out to public comment, and then processing time for the regional board to make a decision after that public comment. I would guess at least a few months would be my guess, but we'd have to look at examples from LA County to see how long it took those to pass through. We can't predict how long the regional board will need to review it.
Thanks, Haley. Another question from Drew Taylor. It looks like he was poking around the GIS mapping tool, and his question is, are the NOAA rainfall events listed 24-hour events? Yes, they are. The contours created from the NOAA Atlas 14 data, and they are 24-hour values. And next up, I'll ask Peter, one from FICO Allen here. Can bioretention systems have underdrains? If they do, what stops the runoff from leaving via the underdrain instead of being stored in the DP zone? And he's referring to slide 40.
Can you go to slide 40?
Yes, I can. I think it was that was an infiltration BMP.
Is this slide 40?
Yes,
So
this is slide 40.
Speaking of bioretention systems have underdrains, thank you. I believe we have discussed this during previous meetings, and so we will be making an adjustment to the 2025 TGM. So bioretention systems shouldn't have a perforated underdrain. Only
if it's sized as infiltration,
thank
right?
you. Yes. If it's
so this is an infiltration BMP example, so I would say no underdrain. Sorry, Peter, to jump in.
Oh no, that's perfect. But if you're sizing it as a flow-through biofiltration BMP, then you would have an underdrain, and you'd have to treat 150% of the SQDV.
Right.
All righty. Next up from Kinsley Hensley. When sizing underground infiltration chambers, do you use INF-2 with the rock section equation or INF-6? Hi.
Yes, let me go INF dash. I'm trying to locate the equation. So the this is something that we'll probably take a look more to provide the response back to Kinsey, but I can provide a general feedback really quick. So when we're talking about the infiltration-based BMP, the concept is pretty consistent. And so if we take a look back at slide 40, you can go back to the slide 40 for me, David. So the SQDV for the infiltration-based basin is the same for all of them. The SQDV. The calculation is going to come down to sizing the surface area for that facility. So for the sizing of that facility, it's simply the equation is simply the SQDV divided by the depth of that facility, right? And the depth of the surface-based infiltration without any rock or anything like that, it just an opens. It's going to be the DP mostly. But if we are talking about let's just say an underground infiltration basin, then in that case, it's much more appropriate to utilize the second equation, which is shown here on the bottom right-hand corner, where it says infiltration trenches or aggregate field dry wells. So in those cases, the underground infiltration basin is going to use that equation because it does take in the aggregate rock. But in this case, there is no ponding depth. So the DP essentially disappear. And the NT multiplied the DT is going to be the governing section. Of course, the porosity of the underground basin are typically much higher than 32%. So in that case, it could be, as much as 75% for some of the system. So again, in that case, you just have to making sure that the DP is indeed 0, and then using the NT multiplied by the DT accordingly. And I will make sure to go back to your question and provide additional information as we provide the written responses.
And I would add to that, I've seen it done both ways through the county. And I've seen it done adequately in both ways. It depends on your calculation method. So using INF6, I think in the past I've seen HydroCAD models supporting those calculations. So I would say it's really important to talk to the local land use authority about your process that you're thinking of moving forward to show sizing if you're trying to choose between those two options.
All right, Kinsley's got another question. Why is there a limit to the tributary area for the planter box option? Is that flexible depending on the size of the planter box and the way you distribute the roof drains? Haley?
I think I'm actually going to throw that to Ty. Ty, do you have thoughts?
I don't necessarily understand the question to its full extent. If Kinsey, if you can type another explanation to that, I would appreciate it. But I will provide the response, generally speaking, that we don't necessarily want to limit the capacity of the system, not necessarily. So if you have a roof drain, which is rather large, and you want to drain that into a planter box, right, for treatment, I don't think we as a public agency, we would be happy to work with you. But as far as I know, I don't think there is a tributary. Yes, thank you for Nicole for talking about the 50K. We'll probably have to revisit that as a committee to understand the limitation and why it is there. But as the local agency would be happy, for me anyway, I'll speak on the city of Oxnard, would be happy to work with you on that limitation.
That might be something that was carried over from the last version of the TGM that we could review.
Absolutely.
And like I said during my presentation or portion of the presentation, this is that opportunity to reach out to the local land use authority to ask questions. If there's a constraint in the design criteria of a specific BMP in the TGM that is somehow challenging to meet given layout and site design, reach out to your local land use authority and ask these same questions. And we might be able to work with the design or increase the tributary area for certain situations.
All right, and Nicole's got another question here. If I have a site where infiltration is infeasible, can I use a proprietary biofilter if it's sized to treat the biofilter design storm volume, and I can show that it will provide better water quality than a planter box? Peter? Ty?
I can take that, David. As presented in the MS4 permit, a proprietary device has now been located to the flow-based treatment, which has to be approved by the regional board. So our recommendation is for that project in particular, you want to go to use the biofiltration first method to evaluate the potential of where you can place the system. But to answer your question, the answer is yes and no. No, we cannot approve it. Yes, the state may be able to prove it through this TAPE certified process. Peter or Haley, do you have any more to add to that?
I would just note that it would require the regional board approval. That's the big no.
All right. And next up from Kurt, are the TGM GIS layers hosted on the Ventura County REST server? I don't know what the REST server is. Does anyone? Kurt, you can, if you want to chime in and let me know.
I think you're the person to answer that, Dave.
Not sure what the REST server is, but all the layers are on the Ventura County Public Works GIS viewer, and the link's in the chat there up above. Hey, Kurt. All right, can't hear you, but you can type it into the chat, and I can follow up with you on offline. But they are all the layers, applicable layers that you need are on the Ventura County Public Works GIS viewer. Okay. Let's see. And then I think we addressed the 15,000 square foot tributary area limitation. That one will be addressed in the written response for Nicole. And then there's a note from Mark Gray.
I think we missed one, Dave. Jose asked about the BMP on slide 41. We didn't address that one yet, right?
Oh, no, nope. Yes. Does the Jose from ECG, does the BMP on slide 41 require board approval?
So no, is the answer. So this is a biofiltration BMP sized by stormwater quality design volume instead of flow. So it does not require regional board approval. It can be approved by the local permitting authority.
Okay, and then Vico's got a question here. Whose responsibility is it to make sure the bioretention or biofiltration media meets specifications? Can you get confirmation from the provider? How do you plan on enforcing media specifications?
So that'll be up. Go ahead, Ty.
Yeah, I can take that. And Haley, feel free to add in. Just as anything on the project site, whether it's water, sewer, storm drain, pavement section, it is the responsibility of the project engineer to making sure that the appropriate products are being submitted for review and approval to the channel. So we would make sure that the project engineer provide confirmations that the soil media is meeting the intent of the TGM, if that is something that is conditioned by the local governing agency. So, Haley.
Yeah, I was going to note that it's going to be under review of the local land use authority. So they would be the one reviewing.
And then I see Kurt followed up the REST server host county layers and lets me load them directly in GIS applications. We don't have that set up. but I will make a note to reach out to the GIS team here regarding that, Kurt. Josiah has a question. Historically, K through 12 schools have been exempt from MS4 permit post-construction stormwater requirements. Is this still the case?
I can tell for the city of Oxnard, schools are not exempt from MS4 permit unless they have their own MS4 permit from the state. So for the city of Oxnard, all of the school within our city limits has to go through the city's compliance and review for stormwater purposes.
So basically it comes down to, do they need a permit from the local land use authority? Because that's what all these requirements are tied to. The cities and the county, when we issue a grading or building permit or a planning permit, we have to meet these requirements in order to issue those permits to the project. So if the project is subject to permitting from the local land use authority, then it would be subject to the requirements. If it is not subject, because it is subject to alternative permitting requirements, then it would not be subject to these requirements.
All right, it looks like that's the end of the questions in the chat. So I'd encourage anybody, while you're hot on the TGM topic and have at the top of your brain, add any questions now while we have the experts ready to answer. And as mentioned, a recording of the presentation will be emailed out to everybody along with these questions with written responses. So we'll get those out likely probably within a week or two. And we'll have the video recording will be up on vcstormwater.org, and that's where the link will take you. All right, Kinsley's has a question here. Has there been any thought by the committee and local agencies to identify sites that would perform better for groundwater recharge and implement development fees?
We've done a little bit of research into it, at least into the process that it would take. It's a process to set up, and we would have to go through regional board approval. So we don't have something like that ready now.
I would say for the city of Oxnard, typically for a stormwater-based project, is run through a CIP capital improvement program on a different lane, if you will. And so while the concept of having that project be the offsite mitigation for better infiltration for groundwater recharge is a really good idea, the timeline and the complexity, including the funding and the different requirements, oftentimes don't align very well. So the intent is there, it's just the execution part is going to be quite complicated.
And just want to note in the chat, Jim Taylor noted that the schools are under the office of the state architect and do not typically have to obtain a local grading permit. However, if they intend to discharge to the local MS4, as he said, without their own NPDES permit, then they must comply with the local MS4 requirements, as Ty mentioned. Thanks, Jim.
Yeah, thanks, Jim.
Okay, giving everyone a few more seconds to fire off those questions. And as mentioned, with any of these questions, specific, site-specific, project-specific, please reach out to the land use authority representative you've been working with. They should guide you and in the right direction. All right, I don't see any other questions. So I would just like to thank Ty, Haley, Peter very, very much for sharing your knowledge and expertise with the group. And thank you to everyone that attended. Really appreciate it. We had a great turnout. I think we got upwards of 90, so that's great. When the recordings come out, please share them with your colleagues. And think with that, we will adjourn this workshop, and thanks again, everybody.
Thank you, everyone.
Thank you.
Thank you, everybody.
Thank you.